So let's take a look at two common uses of arrays, searching and sorting. Searching an array, it's a very typical use of arrays along with sorting. All our examples use arrays of ints, but these kinds of operations like searching and sorting can also be used with arrays of, let's say, other types like floats, doubles, things like that, and also probably it's more useful when you have arrays of objects or multidimensional arrays. So searching is pretty straightforward. I don't think I want to spend a whole lot of time on this. There's a nice example in the book of searching. And of course, the most common kind of search is linear search. You start at the first location and then go down the entire. So we start at index equals 0 and then go down to the end, or through all of the locations, all the elements of the array. So let's say we call this search with an array. We say, since this array is just being searched and not sorted, we make it a const, so that there's no way that this function can modify this array. This array. In general, I would say make everything const as much as possible, and only make things not const if you really have to. Not everybody does this, but I would say it's highly advisable to prevent bugs. Okay, so as with any array, you want to pass in the size as well. And then let's say, as with array, in any array, we pass in the number used or the size. In this case, the number used tells us how many locations in the array are valid. And so the idea being that not all locations in this array might be used. And we use it in our loop. We'll use that number used variable. In this loop, we start at index 0 and look through all elements up to number used. And if the thing that we have in the array at a particular index is exactly what we're looking for, so here's the key. It's usually called the key. The thing that we're looking for is the target, and then if we find it, then we return the index in array A where we found the thing that we were looking for. So we need a bunch of things, a bunch of pieces of information. The array itself, how many locations are valid, how many locations we need to search, the thing that we're looking for, in this case an int. And so it's a nice simple example. You could also be searching for strings and stuff like that, but let's just keep it simple. And then finally, what this function should return is a valid, that is a value between 0 and number used if the thing was found, and something else to indicate that we did not find the target. In this case, we used -1 to indicate that whatever we were looking for was not found. Okay, so nice simple example. Searching is pretty straightforward, and that's linear search. Of course, there's other things like binary search. Most of you probably have at least heard of it. Okay, so next up, the book goes through a sorting algorithm. This should say selection sort. And that's that's a simple ways to sort an array of values. And it can be an array of ints or floats or doubles, strings later on too. But for all the examples in this chapter are arrays of ints. Since this is something that I'm guessing you have seen, I don't want to spend too much time on this. Couple of things that I want to point out is that if you use selection sort, it's very handy to be able to swap values in an array. So take the contents of array location I, swap it with the contents of array location J. If you're going to do that a lot, it's nice to have a function like this which uses pass by reference. So the swapping, and here it is. It's mostly here. I think it's essentially all of it is here. This is how you swap using pass by reference. Very nice thing to have to be able to do. So this is not available. No, you can't do this in Java. Okay, so oh yeah, there's one more statement after this slide. I'm just going to go down to the next slide, and there is the one last statement of the swap. So you might want to take a look at that. That is a nice, handy little function to have access to. I want to end with some notes about multidimensional arrays. Multidimensional arrays just have more than one index. So typical use is for matrices. Matrices as in math and linear algebra. Those of you who have taken linear algebra, you know what matrices are. There's also other uses for multidimensional arrays. And so you think of this as rows and columns. This first index, in this case 30, that's the rows. So it goes 0, over here, 1, all the way to 29. And then the second index, you think of that as columns. So the very first time it's 0, column 1, and so on up to column 99. That's one useful way of thinking about two-dimensional arrays. That's not the only way. You can actually flip the order, sort of, at least conceptually, but this is usually, when we think of two-dimensional arrays, we think of this as the rows and this as the columns. And so if you had to do matrix algebra, like those of you who've taken linear algebra, usually, almost always, this is the row and this is the column. Sometimes you have to flip the order, but usually row column. Okay, so C++ does allow more than 2 indices, and right now, it used to be there was a limit, but right now I believe the current version of C++ allows any number of indices. Typically, you don't see much more than 3. It's just hard to visualize and hard to use. Most common multidimensional, of course, is 2. Two-dimensional matrices. And once you've set up the array, you use it in a very similar way in both C++ and Java. Java gives us actually a little bit more flexibility, and that kind of flexibility as far as the size of each row, that kind of flexibility we will see later on in roughly chapter 10 when we can use dynamic arrays. So right now we'll just assume that the size of each of these things, and this is called the dimension. So this has dimension 30 and dimension 100. Sorry, let me take that back. This is the first dimension, sorry, and this is the second dimension. So when in Java, let me just back up again. So first dimension, second dimension. In Java, you could have this first dimension be 30 and the second dimension depend on the row. And chances are you've done that. You've seen it in CS 161 or 162, or wherever you saw multidimensional arrays. I hope you've seen it. It's not something that's quite commonly used, but every once in a while it is useful to have this thing, the size of the second dimension, depend on the row number. And that's possible in C++, it's possible in Java. Okay, if you are passing a two-dimensional array, or actually even a multi-dimensional array as a parameter, let's say two-dimensional, the first dimension size is not given, and it's provided as a parameter. And it's usually the second dimension is given. You do have to have that. And that's usually how arrays are passed. That is, two-dimensional arrays are passed to a function. So once again, you pass in a two-dimensional array, and so this is a parameter name p, and whatever you're passing in as argument, the size of the first dimension is passed as the second parameter. The size of the second dimension is passed in as it's actually declared right in the function, so it's not of course you don't have to pass in anything. You just, when you call this, you just call it with whatever name the array has in the calling function. Alright, so that's about it for this chapter. I hope arrays are pretty straightforward. You know, there's some important differences between C++ and Java. I hope you got the gist of it. Mainly, arrays do not have the dot length. There's no such thing in C++. Of course, Java has it, and it makes arrays very nice to use. So we could run into problems in C++. We try to avoid them by passing as a parameter effectively the length of the array. All right.